Hello boys and girls, welcome to another episode of FoulkesBrau. There on the bench we have one of these Sony PlayStation power supplies to look at. So this is not really a political channel, so I don't really want to talk about the things going on in South Africa at the moment. I'm sure those of you on social media have seen my tweets and retweets, and those of you overseas watching the news are aware that something is happening in South Africa. We have this so-called looting and rioting in South Africa, which is very strange to me because this really started last week Friday. Today is Thursday, so 6 days ago, and we've only sent in 2,000 of our South African National Defence Force to quell the looting, which makes no sense. And even then, the orders given to these people, or how would you put it, the reports coming from the people on the ground say they're not seeing the police or the defense force where this is going down is very suspicious. Anyway, it will come out in the wash, and like I said, this is not a political channel, so let's jump on the bench. Let's have a look at this power supply and let's see what's wrong with it. Right, so here on the bench we have our power supply. I'm not even going to turn it on. I'm just going to take it straight apart. I think it's 4 little screws. The owner tells me when he switches it on, it tries to come alive and then it dies. So it starts and stops, starts and stops, starts and stops. So we'll just open it, we'll have a look. See together, like I say, there's 4 Phillips screws in here. There was 4 little feet. Obviously the owner took this out and those are gone now. Not a train smash. So there we go. I'll just crack it like that. Really not much to this. This is okay. Right, so here we go. Here is our power supply, and straight off the bat, let's just lock this. We'll change the exposure a little bit. How do I zoom in here? Let's do that, and we'll zoom in a little bit more. I've changed cameras, so I'm now filming with the iPhone 12 Pro Max, and it seems to be a bit better to me. But anyway, so straight off the bat, what can we see here? That capacitor there is bulged. Oh, shame. Let's zoom out and we can have a look at the circuitry. So I bet you that is the problem. So let's have a look at the circuitry for this switch mode power supply. Obviously we've got our AC mains coming in. Gets rectified there, 4-wave bridge rectifier, bulk storage capacitor. We have a FET of sorts down in there. That'll be driving this transistor, nice big fat resistor down there, so obviously current sense. Then we've got a transistor down here and what looks like 2 transistors in there. Okay, let's not worry too much about that. We've got our primary winding on here, a diode down there, and these 2 capacitors and a choke, and obviously our fan goes off there. So we look on the underside of the board. Well, there's not much here. There's the bottom of that FET, the switching FET, the main FET, so we can see somebody's been in here and obviously didn't pick up the fault. So what you've got your separation between your primary and your secondary side, and that capacitor across the primary and secondary, so noise suppression capacitor. I'm not going to check, it should be it's an X or Y class capacitor, probably not. The gate of our FET, that pin on the leftmost side of your screen, through this resistor, through a wire link to this chip here. So this chip is what is controlling our switching FET down here to switch this transistor. And then we've got what looks like, yes, down in there, feedback from the optocoupler to this chip. So obviously we've got circuitry over here, some capacitors, some passives up here, capacitors and resistors. So that'll all be feedback as to how this circuit is doing. That little IC down there, I have no idea what it's doing, but there's some transistors associated with it, and so and this transistor up here, so I wonder if that's not another. Yes, it could be, indeed it could be. So there's the gate on that side of those transistors, and it's coming to here, the source on that side there of the transistor, and the drain comes through to this point here, and what is there? It's across the capacitor. But that's the ground of the capacitor, so that's fine. Across, what is that, a wire? Across our inductor. Aha. Okay, so this side is our power, it looks like. Going, no, have I got, no, this side is our power. Oh no, I've got it all wrong. It looks like this side is the power, and that side is the neutral. So this looks like another switching IC now for the low side. So what this could be, so what I'm suspecting, because of that inductor there, that FET there, yes, and this capacitance, so this IC down here will be for power factor correction. So here we're switching in a half bridge configuration, so that chip switching that FET in there, well, that chip is driving the FET, which is switching this transformer, the secondary side of this transformer. We are doing power factor correction through that inductor. But anyway, that capacitor is a problem. So let's see. Let us plug it in. So I'm going to just set this up and we'll come back and plug it in. Right, here we go. Here's our plug. I'm going to plug it in and we'll see what it does. Oh, there it starts. Of course, I can hear it whinging away. Okay, while we add it, let's measure. Let us measure DC volts. 7 volts on there, nothing on there. Let's see what we have on our output. Okay, here's our ground in here. So I'm just going to measure in here. Don't mind if I do. Nothing there. Nothing on the output. We've got our +5. Nothing on +12. Okay. Let's have a look at this FET. We've got 12 volts on the gate. Nothing on the drain. What could that be? 5 volts on the other side. Okay, so I'm going to have to check what transistor they've got in there, because this should be switching to ground. We've actually got 12 volts on the floating on here. Okay, let me whack these transistors out quickly. Sorry, the capacitors out, and then we will come back. Right, I just wanted to show you before I take the capacitors out. So this can be a little bit of a trap. So let's see. This is the gate up here. Gate to source. Gate to source. Source to drain. And on this side, that seems to be fine till the capacitance builds up, but that way is short till the capacitance builds up, short. So let's definitely take those capacitors out and we'll come back and measure again. Right, here we are back on the bench and we have my trusty LCR meter. I've taken both those capacitors out. So let's have a look at them. Here's the bulged one, and you can see the bottom is actually coming off. You can see that bottom tab. This one didn't look damaged, looks fine. So let's have a look, see what we are actually going to see. Let's just do this. Okay, the first thing I'm going to do, these capacitors are, let me just take the lock off, rated at 2200 microfarad, 25 volts, so I'll fix the focus there. I'm going to change the frequency to 120 hertz, and we want to measure capacitance. Okay, so what I'm going to do, I'm going to put the capacitor in here at the bottom of these terminals, and let's see what we read. So we're reading a whole 504 microfarad, or we were. Yeah, 500 microfarad. Of course, .7 ohms for the ESR on this capacitor, so it is way out of tolerance. It's measuring a quarter of its capacitance. It's measuring 6, so I would guess about, for a capacitor this size, it should be better than 2 ohms on the ESR. So it's reading 4 times the ESR that it should be. So this capacitor is definitely leaky. It's gone. Let's take the one next to it and let's see how well that is. $1,851 microfarad, and the ESR we're not reading. Of course we can go here. So the ESR is roughly 30 milliohm, and the DC resistance 110. 103, 12 meg. Okay, either way, this one is fine, although I'm going to replace both. So it is always good to have a meter like this. Of course, I'm not looking at the dissipation or 10 theta value of it. I'm only interested in, at 120 hertz, what's the capacitance and what is the ESR value. Yeah, 4 times. So I guess a capacitor of this microfarads, of 2200 microfarad at 25 volts, for the life of me, I seem to remember 2 ohms, although I'm not sure and I don't have a data sheet. But what I do have is, I do have some 2200 microfarad capacitors that I bought a while back. So let us actually have a look. Let's have a look, see. So here I have a 2200 microfarad capacitor rated at 25 volts. Let me put it into the meter. Oh, so it's reading 2 millifarad, if you can see there. So close enough, and the ESR 0. So let's change it. We want to measure the series resistance, 50 milliohm. That's fine. DC resistance, let's wait for it, 70 meg, 42 meg, 36 meg, 33. That's to be expected, it's jumping around, but either way it's still. Let's go back to our capacitance. And tan theta minus 85.2, so it is a capacitor. Delta 0.08, which is, yeah, for a capacitor this size, it should be better than 0.2, so that's fine. So I'm going to pop these capacitors in, the two new ones, to replace the other two that are pretty much shot, and we'll come back and have a measure. Right, so here we are back. We've replaced these two capacitors down here, and I've cleaned up under the board. So the moment of truth. Our red LED comes on. Right, what you can see, well, sorry for bumping you there. Let's put our multimeter on. I've got a couple of wires up here. My hands are going to get in the way. From up there, ground, which is black, to the white, 5 volts. Swap these around. It's always a pain working behind this camera. So ground to there, 5 volts, 12 to ground 0, and there's a control voltage pin to ground 0. So I'm going to measure to the 12 volt rail, and I'm going to try and do this behind the camera. Try not to get my hands in the way. I am going to short out the control and the 5 volts. There you can see 12 volts, and the LED went green, and the fan has started. So there we go, power supply fixed. So moral of the story, it's always good to have a LCR meter like this, but in these switching power supplies, that is typically what goes. Of course, I was talking a little bit of cuck to you. That chip down there is a 7805. It's a voltage regulator, 5 volt voltage regulator. That's obviously giving us our 5 volts down here, the white line, and those will be our 2 switching FETs, high side and low side, for that inductor, again for the power factor correction. So what it's doing is it is shorting the line to ground, and be careful you don't make the same mistake that I made early on, measuring across those and saying, one of them is shorted, the gate is shorted to ground, or the drain is, or the drain or source, or the drain is short to the ground, because you're actually measuring through that inductor. And with a multimeter you are measuring DC resistance. The right way to do it would have been to use this meter, change the frequency up to something like 10 kilohertz, and then, or 100 kilohertz, and then measure the ESR, or the resistance of the circuit, and then we would have seen no short. But anyway, 2 capacitors, brand new, in, and we've cleaned up the underside of the board, and that brings us to the end of this. So let's finish up. And there we have it. That brings us to the end of another video. Rather easy fix if you're going to work on these things. Always check the switching capacitors. They dry up. They're normally underrated. The guys will put in low temperature rated capacitors. If you can, and you're going to put them in there, go for the low ESR types, 110 degrees, 125 degrees Celsius rated capacitors. You pay a bit more, but in the long run it's worth your while. Anyway, as always, I hope you had fun. I hope you learned something. Take care, be safe, and we'll catch you in the next one. Cheers.